Thank you all, and it's a privilege to be here and listen to some of the sustainability and Daniel, fantastic, and all the other work. Try to add to that, I'm an engineer, I've been at it now for 50 odd years. My wife said to me not that long ago, I think it's 15 years now, we're supposed to retire soon, what are you doing next? I'm going to throw every cent that we've ever made into cleaning up stormwater. Because it is my estimate that we're dumping around 130 million tonnes of pollutants into the oceans every year. And guess what? The water that we have is the water that we've always had. 3.5 billion years ago is the science, and says that's when it arrived and it created planet Earth. Planet Earth is a wonderful place because we have water in three phases at exactly the same time: solid, liquid and a gas. And that's what supports this wonderful planet that's green, and weather and climate, it all is managed by water. So what we've done is, in the last 200 odd years, we've polluted all water on the planet except for water that is ice that was formed prior to that period of time. That's where we're actually at. And most of the pollutants are generated, if not all the pollutants are generated by anthropogenic, i.e. human activities. So we've got trees, grasslands, forests, all sorts of wonderful things sitting there, and we cut it all down, we throw down concrete, bitumen, steel roofs, whatever, and we've completely lost that biodiversity that's in the soil, in the groundwater. Okay, it's not a big percentage of the planet, but that's where most people live, and that's where my estimates come from. So I won't bore you with how I got there, but just please accept that it's reasonably well accepted that we consume about a credit card of plastic a week in our diet. We're consuming long-chain molecules. You've heard of the term forever chemicals. We're starting to wake up to the fact that that's all in our food chain. So that's a little bit about us. So stormwater management is where we've focused our effort, and the technology that we've developed, we're moving into other areas in the near future. What we've done is found a technology which works. We commonly have seen systems where there are filters, screens, media and all sorts of things that are used in water treatment. That's fine, but it doesn't work very well in stormwater. Stormwater flushes down. The problem with stormwater is, when's it going to work next? Well, you can't quite predict exactly when it's going to rain next. We've got a reasonable idea. So every stormwater event is a unique thing that happens. What we've done is developed a process called hydraulic separation. It works on a combination of factors, which is inertia, gravitational, electrostatic, and so on. In simple terms, we do use a mesh in our system, but what we're able to do is, if you take a mesh with an opening of, say, 0.5 millimetre, 500 microns, we can remove particles down to 10 microns, even though through that large aperture, and it's by managing the flow in the water. We've done a lot of research to understand particles. We've heard from our mining people and all sorts of things that they've got there. This little thing that, don't know whether you guys can see that started off as a 40 micron particle. So for the first time in the world, we believe in 2013 at Sydney University, we videoed what a particle looks like and identified that why the problem that we solved then was my question: why is it that the sediment beds in Homebush Bay in Sydney were heavily laced with PCBs, yet fish are swimming above it and we're eating the fish? They're that far away from a deadly poisonous environment. The reason for that we found in 2013, and that is because there's a huge amount of forces that are built into particles that attract those chemicals and retain them. So that's why the sediment beds all around the planet, Port Phillip Bay is a case in point, are heavily laced with toxic chemicals. What we've done is developed a technology to remove them without any extra energy. So we use the energy in the flow to separate those pollutants, hold those pollutants so they can be looked after, and we're also doing it in a sustainable manner. We design our systems so that they last for at least 100 years. We're using green concrete, we're using the fibre that Tony Collister talks about. We've created, our whole system is based around recyclable materials and materials that can be reused indefinitely. We're Australian made, we're Australian developed, it's world first technology. We're applying it. We have now probably approaching 550 odd systems around Australia, and 2025 we're pushing hard to go global. We also utilise resources such as NDIS, and the big benefit of our systems is we're able to be compliant at lowest cost. We've developed our systems so that we're reducing CO2. We're getting that audited at the moment. We look at end-to-end life impact. All of our systems can be simply maintained. What's the use of putting something out unless you can maintain it and therefore work for its full service life? We have a hierarchy in our design which is safety, maintenance and compliance. If it's not safe, don't do it. If you can't maintain it, it'll never work, and it has to comply with all of the various things, structural, environmental and sustainability. The reason why our systems are low cost is that we replace many components that are currently used in stormwater management globally. You'll see down on that diagram there, the pretty picture up the top is our system. It removes gross pollutants, trash and litter, sediments, nutrients, toxic chemicals and oils, and I'll show you oils in a moment. So we are typically 45% lower cost to install, 87% lower cost to maintain, and over a 25-year life cycle compared to other methods, 77% lower cost. Why? Because we remove all of the bits and pieces that people sell. You go down to any trade suppliers and they'll talk about pit baskets and all sorts of wonderful things happening. We replace all of that with one unit. So we turn bottom right-hand corner, biofiltration basins. That's a great idea. They work, but they don't work when they're clogged full of pollutants. They are meant to replace wetlands. Natural wetlands don't have any way of removing polystyrene, don't have any way of removing total petroleum hydrocarbons. So what we've done is to take all of that process and upgrade it even further. We've had it tested against international codes, and what we've done in the previous slide, we can actually remove oil content down to 5 parts per million, or 5 milligrams per litre. In this example here, the testing that was conducted by BP themselves, unannounced, I got a phone call from an engineer for BP and said, "Leo, yes, it's Steph here. Yes, we've done some sampling of a service station up at Maruka in Brisbane." "Oh, yes, it's okay." "Oh, thanks, Steph." She said, "We measured it and we put it to ALS NADA certified laboratory. They tested down to parts per billion and couldn't find any traces of total petroleum hydrocarbons, nutrients, toxic chemicals or anything from a service station." So, and all of that happens in one unit. It's manufactured from green concrete, stainless steel, reuse it endlessly. And the trick to it is not only separating the oil in the process that you see in the top 3 photos, but we've also introduced a 2-metre deep water trap so that any leftover residual materials can't escape. The only problem people have got to convince that is EPA. So anyway, we're getting there next year. So that's a little bit about us. Thank you very much for your attention.